that we have to apply trig, but we have to kind of figure out some pieces of this before we can apply the trig. So we have two circles here. They're equal sized circles. The radius is the same. And we have this length A to B is 10 centimeters long. So I'm just going to highlight that. Make sure that I keep track of that information. Okay, so this AB length here is 10 centimeters. And because of the symmetry of this diagram, we know that the other side must also be 10 centimeters. Okay, and again, whenever we have symmetry, we always want to apply the properties of symmetry. And we want to figure out how long the radius is. Okay, we want to know this length here. So we have this length, which we're trying to find. Okay, and we know that this length is R, and we also know that this length is R, and this length is R, and this length is R. So this the horizontal length is going to be 3R. Okay, so how can we work this out? We really just need to either solve for the vertical length or the horizontal length here. Okay, but we need an angle here. So we only have one length in this right triangle. So how can we convert this shape into an angle? And that way we can use this length of 10 and have a ratio to work with. So there's a few ways to do this. We could use Pythagoras and write an equivalent in terms of R to solve for the length of 10. We could also apply trig, and I think we should probably apply trig since this is a trig unit. And we'll show you how to do that algebraically after. So I know that I'm going to call this angle theta, and I know that tan theta is equal to a rise of 1 R compared to 3R. And what ends up happening then is we know that these R's cancel out. It's just a ratio of 3 to 1 or 1 to 3. And I can solve for the angle theta by using my inverse function. So my tan, inverse tan is going to give me the angle. So tan theta equals 1/3. So the inverse tan of 1/3 equals the angle theta. So at this point I need to convert that ratio into an angle. Okay, so my angle works out to be 18.43 degrees. Okay, well if that angle is 18.43 degrees, I can now use that triangle and I can use this side R, unknown side compared to the hypotenuse. So this is going to be opposite to hypotenuse. So katoa, opso is SOH, so sine. So we're going to use the sine ratio. So sine of the angle theta, in this case theta works out to be, we worked it out to be 18.43 degrees. So this is why we needed to work out the angle first, because we're using that angle then to then generate a ratio. Okay, so we're going to generate, in this case, a sine ratio, which involves the side that we need to work out. Okay, so the tan ratio used sides that we didn't need to solve for, but the sine ratio involves the side we need to solve for. So I end up with R over 10, opposite over hypotenuse. So I need to go back to my calculator. I need to convert that sine ratio, the angle, back into another ratio. Okay, so it's going to be 0.3162. Okay, we'll compare that to 1, and that's going to be R to 10. Solving for the radius algebraically, we get 3.16, and that is the radius. Okay, so there's our answer. The radius of the two circles is 3.14 centimeters. Okay, so I'm just going to show you quickly an alternative to this. So this is a completely different solution that doesn't involve trig. Okay, and this is doing it in this way here. So I have R, 3R, and this is 10. So what I'm going to do is express that length in terms of R, and then I'm going to solve for R. So If I use Pythagoras here, I get r squared plus 9r squared, which is just 3r all squared. Make sure you put it into brackets because we need to square that whole thing. I see lots of people just squaring the r, but we need to square the whole thing, and we'll call that x squared. Okay, and then we end up with r squared plus 9r squared equals x squared. So 10r squared equals x squared. Okay, and then if we want to replace that x with 10, we can solve for r. So there's a few ways we can do it, but I'm just going to plug in 10 for our x, and then I can solve for my r. So I end up with r squared equals 100 divided by 10. So r squared equals 10. So I square root 10. I get plus minus root 10, which I don't want plus minus, so the answer is just going to be square root of 10. And if we take a look, square root 10 on my calculator, it gives me the exact same answer as I got from my ratios, 3.16. Okay, so this is approximately equal to 3.16. And so this solution here didn't involve any trig, really. It didn't use the ratios or anything. We just used the side lengths and we used some algebra to solve that. But we get the exact same solution. This one here, again, we use the ratio of the shape of 1 to 3 to get the angle. And then we use that angle in a sine ratio to solve for the unknown side r.